Hello everyone. Under Fundamentals of IoT, Unit 1, Basics of Networking is going to be discussed now. So in this lecture, we'll see what is an RFID. RFID stands for Radio Frequency Identification. Data digitally encoded in RFID tags, which can be read and by the reader. So RFID is an identifying the signals, radio frequency, to the certain level, to the frequency. The signals are going to be identified and the data is going to be read. Okay, somewhat similar to our barcodes. Like when you are scanning barcodes, to certain distance, it is able to access. From certain distance, you can able to read that barcode. Okay, so data read from tags are stored in the database by the reader. So as compared to the traditional barcodes and the QR codes, RFID tag data can be read out the light of the sight. Okay, so this is a basic introduction part of RFID. Okay, we'll see the features now. The RFID tag consists of an integrated circuit and an antenna. Okay, the tag is covered by a protective material which also acts as a shield against various environmental effects. It means a tag is covered by a protective material. So when the wire or the data, the tag which is integrated, the circuit or an antenna, which is covered with an protective material, so that it can be protected from the environmental effects. Okay, tags may be it may be a passive or an active. So passive RFID tags are the most widely used. So passive tags have the power by the reader inductively before they can transmit information, whereas active tags have their own power supply. It means passive tags have power by the reader indirectly. So before they are transmit information, before they transmit that information, the data is going to be read and stored in a database. When we go for an active tags, there is an own power supply. So whenever they're transferring it, that the information is going to be transferred immediately. Okay, so the working principle, how actually this RFID works. So derived from automatic identification and data capture, AIDC. Okay, AIDC stands for automatic identification and data capture. It is a technology which performs object identification, object data collection, and mapping of the collected data to computer systems with little or no human intervention. So AIDC uses wired communication. Okay, it is a wired communication. RFID uses radio waves to perform AIDC functions. So whatever the functions that it has to perform, RFID is going to be performed with the help of which uses radio waves, and it is going to perform the task, the functionalities of AIDC. What are the functionalities of AIDC? It performs what? Object identification, object data collection, and mapping the collected data to the computer systems. Okay, so this is a basic idea of RFID. The main components of an RFID system include an RFID tag and a smart label and RFID reader and an antenna. Okay, so look at this diagram. You can analyze something, right? RFID, the magnetic lines. Okay, these are some magnetic lines. It's giving some force to these tags, and the data is available in the data. The items which are tagged are present in the like some area, and this is going to be covered. Okay, RFID tag and the contentless RFID reader with what 13.56 megahertz power. With this power supply through magnetic lines, the tag with the help of RFID tags, the data is going to be retrieved. Okay, the power supply and all is connected, is linked up with the softwares. Okay, So the basic applications of RFID is inventory management, assisted tracks, personal tracking, controlling access to restricted areas, ID badging, supply chain management, and counterfeit prevention. It means, see, inventory management, assist tracking, personal tracking, like these are all different applications where RFID is used. Okay. So now we'll see the functionality based on protocol organization. Okay. The basic functionality is how the basic functionality is happening with the support or based on IoT protocol organization. So connectivity, identification, communication, discovery, data protocols, device management, semantic and multi-layer framework. These are all different protocols, like they are different functionality, okay, based on protocols. Okay, so if you can see this, connectivity can be done using 6LoWPAN or RPL. Identification of the elements can be done by using EPC, UCODE, IPv6 URLs. Okay, communication or transport. The basic idea here is you just try to analyze, see, connectivity, how this virtual world is going to connect with the system, or how these two things are going to be connected using either Ethernet or Wi-Fi, like that. There, this concept comes, the connectivity. Identification is that which device you are connecting, which barcoded or which system that you want to connect. Identification. Okay, when you talk about the communication or transport, how this data is going to be transmitted using Wi-Fi, Bluetooth, or LPWAN. These are different communication protocols or transporting levels in order to transfer data from one end to the other. So discovery is using physical web, MDNS, DNSST. Okay, data protocols are MQTT, COAP, AMQP, WebSocket, Node. These are all data protocols. Data management is TR06OM. So device management, how their device is going to manage using these two elements. Semantic, JSON LD, web thing model. These are semantic analysis. Okay, where next coming to this multi-level frameworks. These are different multi-level frameworks where these concepts can be applied. We'll talk about MQTT. Okay, MQTT is a message queue telemetry transport. Okay, ISO standard, ISO, IEC. This is a standard which is used for, which is fixed for message queue telemetry transport. Okay, it is a publisher subscriber based lightweight messaging protocol for use of conjunction with a TCP or IP protocol. Okay, what does it mean? It is a subscriber based model, okay, which is a lightweight messaging protocol. Like, so whenever publish subscriber is nothing but a publisher is going to publish the document or a file into the system, and the subscriber will able to view the data or to access that data which is published by the publisher. Okay, there's a simple concept. So publisher is the one who need not be aware of who are their subscribers. And here, similarly, subscriber is also need not, he doesn't require the publisher who is publishing the file. Okay, MQTT was introduced by IBM in 1999 and standardized by OASIS in 2013. And the design to be provided connectivity. Okay, it is designed to provide what for connectivity. Mostly we'll use embedded systems. Okay, like Arduino or Raspberry Pi. These are embedded systems. We are with the help of those devices, we are going to connect between applications and middlewares on one side and networks and communications on the other side. Okay, clear? Applications and middlewares are at one side. Okay, and to transfer the data, networks and communications plays another role in the other side. Okay, so a message broker will be present in between publisher and subscriber in order to transfer the data between these two persons. Okay, a topic to which a client is subscribed is updated in the form of message and distributed by the broker, okay, in the form of message. Okay, it is designed for remote connections, okay, limited bandwidth, small code footpath or footprint. Sorry. So these are three different like applications or design in order to use this kind of concept where publish and subscriber model, remote connections. Okay, limited bandwidth. When you have a limited bandwidth, in those situations you are going to use this publish and subscribe model, where you can give the messages and this broker is going to transfer that message to the receiver. So small code footprint. Okay, look at this components. Here we require the publishers, subscribers, and the brokers, right? So publishers are those lightweighted sensors. Okay, subscribers are those applications instructed in sensor data. Now these brokers are connect the publishers and subscribers, classify sensor data into topics. They classify the sensor data into topics. So the methods which comes under is MQTT, message queuing telecast technology. In that, methods are connect, disconnect, subscribe, unsubscribe, and publish. Okay. See, if you can relate this diagram, temperature sensor is there. The data is going to be transferred as MQTT broker. Okay. Now this broker is going to publish the data to this laptop. Okay. Or a mobile device. Now the subscribers are going to give instructions or the information to the broker. Okay. And then how, what kind of actions it has to take, the broker is responsible. So now when we move on to this next topic called communication, the protocol uses publish subscriber architecture. Okay. Which I have shown in the previous slide. You can see. So HTTP uses request response paradigm. Okay, publish subscriber, event driven, and enables messages to be published to clients. Okay, the central communication point is the MQTT broker, which is in charge of dispatching all messages between the senders and the rightful receivers. Okay, each client that publishes a message to a broker includes a topic into the message. That's it. So the topic is routing information from the broker. Okay, got my point? So from now, you can just relate. So each client that wants to receive messages from subscribers to a certain topic, and the broker delivers all the messages with the matching topics to the client. Therefore, clients do not have to know each other. That is what I have told you before. The clients need not know about each other. They just want a message or the information. They're only concerned about that. The only communication over the topic only. So the thing they communicate for the topic, not just for their personal. Personally, they need not know who is sending or who is receiving. So this architecture enables high scalable solutions without dependencies between data producers and data consumers. Okay, so topics are, as we are saying, different topics, right? The topics are simple string. Okay, like temperature data, send temperature data to a living room living room. That could be a house, living room temperature. On the other hand, the client might be a mobile device, can be subscriber to the exact topic, or on other hand, it can be a wildcard. Okay. So the subscription to house or temperature would result in messages sent to the previously mentioned topic, that is house or living room temperature and all. So as well as any topic with any arbitrary value in the temperature or a place of the living, such as house, kitchen, temperature. These are all different topics when we are when we want to consider about the transmission of data. The plus sign is a single level wildcard. The plus sign is a single level wildcard and only allows arbitrary values for one hierarchy. If more than one level needs to be subscribed, such as the entire subtree, there is also a multi-level wildcard. Okay. So these are the different examples for MQTT. Okay, Facebook Messenger, Amazon Web Services, Amazon Azure, Everything IoT platform, and Adafruit. Okay. So we'll end up with this session. Okay. We'll move on to the next topic called SMQTT in our next lecture. Thank you.